we had that is last lecture. So electric charges and fields we solved certain numericals also. What and all we have been covered so far in our lecture with a quick just a recap and then we will continue so that the continuity is not lost. So என்னோட ஸ்கிரீனை நான் ஷேர் பண்றேன். So let me know if it is visible. எல்லாராலையும் பார்க்க முடியுதா ஒரு வாட்டி செக் பண்ணிக்கோங்க. ஏன்னா லாஸ்ட் டைம் it happened so that it was not being shared. So அதனால ஒரு வாட்டி செக் பண்ணிக்கோங்க. Yeah, I hope you are able to see the screen. Yeah, you are able to see the module பார்க்க முடியுது நம்புறேன். Okay. So electric fields and charges basic நம்ம என்ன பார்த்தோம், different methods of charging ல இருந்து நம்ம ஸ்டார்ட் பண்ணோம். If you can recall, so I would love to hear from you. So யாரால ஒரு quick summary பண்ண முடியும்? நம்ம methods of charging first நம்ம போலாம். So what are the different methods of charging with examples? Yes. Any volunteers?
Charging by friction, charging by conduction, charging by induction.
Induction, very good. So charging by friction we had, by conduction and by induction. Okay. So examples கொடுக்க முடியுமா? Can you give me examples, real life examples?
Charging by friction, glass rod rubbed by a silk cloth.
Okay, that's correct. Glass cloth rubbed by a silk cloth is charging by friction. Okay. By conduction? So charging by conduction, how can we give examples?
Rubbed on glass rod, charged with balls.
Yeah, you bring one charged pith ball next to another uncharged pith ball and just bring it in contact. Appo ungalku aduvum charge agum. Yes, that is one way. Okay. By induction appdin sonnona, what is the difference? Charging
without direct contact.
Yes, without direct contact. Contact illama nama charge pandradhu dhaan it is charging by induction. So that is the basic idea. Friction la you involve rubbing of two surfaces. Friction is involved where one surface is rubbed past the other and you charge it. Second, by conduction it is brought in contact. An uncharged conductor and a charged conductor are brought in contact to charge them. And third, by conduction method, so what we are doing is without bringing them in contact, we are trying to charge them. So that is the basic idea. Great, very good. So you guys have an idea about it, fair idea about it. Okay. So and then adukapra nam Coulomb's law பார்த்தோம். So Coulomb's law யாராச்சும் சொல்ல முடியுமா? ஒரு basic idea அப்புறம் ஒரு formula introduce பண்ணி. What is Coulomb's law?
That is directly proportional to Q1 Q2 divided by R square.
Yes. The Coulomb's force of attraction or repulsion between two charges separated by a distance of r in space is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Yeah. Yes. So nama proportionality sign remove பண்றச்ச what do we introduce in that place?
K.
Yeah, we introduce a proportionality constant. What is the name of that constant? அதுக்கு ஒரு பேர் இருக்கு, அதுக்கு ஒரு வேல்யூ கூட இருக்கு. What is that?
1/4 pi epsilon naught.
Yes, K is nothing but 1/4 pi epsilon naught. So that is your constant. Yes, Coulomb's constant அப்படின்னு கூட சொல்லலாம், whose value is 9 into 10 power 9. So that is the value of K, the magnitude. Okay. So that is what is the Coulomb's law. Okay. So and force due to system of charges kuda nama paathom, and we also got the expression for the force due to system of charges. Okay. So now we will move on after we had a recap. And electric field lines also we saw. What are the different electric field lines? So we are now moving on to the next part. So electric field paathitu nama apdiye polam. So continue to irukum. So we'll see the electric field and then move on.
Electric field. An electric field is the region surrounding electrically charged particles. Let's take a look at how these charged particles can cause electric fields. To begin, we'll rub a glass rod with a silk cloth. This rubbing will remove some electrons from the rod, leaving it with a positive charge. Now we'll bring the rod near to a pith ball. When the positively charged rod is placed within the vicinity of the ball, the electrons in the ball will move slightly towards the rod, while the protons will move slightly away from it. Because the electrons are closer to the rod than the protons, the ball will swing towards the rod. The glass rod is said to have an electric field. In a similar way, a Van de Graaff generator, when charged, will attract a metal ball brought near it. An electric field will be created around the generator, influencing any charged or uncharged body entering the field. Here, the generator is the source of charge, while the metal ball is referred to as the test charge Q. The strength of an electric field is a vector quantity, having both magnitude and direction.
Okay, so ipo just idukku vanda previous concept nama paathapo, so we saw that there is a charged object. So when nama first vanda glass rod vanda charge pannitom, how did we charge it? By rubbing it past a silk cloth. So when you do that, silk cloth is going to get the negative charge and glass rod gets a positive charge. Yeah, that is because glass rod is losing electrons to the silk cloth, thereby getting a positive charge, and therefore silk cloth becomes negatively charged, isn't it? So that was the first step. So that is charging by friction. So that is clearly understood. Yeah. Now next, what did they do? Using a clamp stand, an uncharged pith ball was suspended. So the glass rod was brought close to the pith ball, but not in contact with the pith ball. So contact illama, we just bring it close to it. Appo nama enna paathom? What did we see inside the pith ball? The charges, based on the charges in the pith ball. So a pith ball which is uncharged has both positive and negative charges in equal amounts. Yeah. So the net charge remains 0. Plus 5 minus 5 coulombs அப்படின்னு சொன்னேன் அப்படின்னா obviously the charge வந்து 0 தான், overall charge 0 தான், but அந்த plus 5 minus 5 உள்ள distribute ஆயிருக்கு. That is the only meaning. So when you bring the glass rod, what happens? Only the negative areas, that is the electrons, are getting attracted towards the glass rod. Because properties of charges, we know the properties of charges that opposite charges attract each other. Glass rod la irukkudiya positive charge vandu pith ball la irukkudiya negative charges mattum attract pandrathu, wherein the positive charges in the pith ball are getting repelled by the positive charges of the glass rod. Adanala da and orientation vandu nama paathom. You could see that both the charges, negative and positive, got aligned superficially in the extremes of the pith ball. Okay, so that is what was observed. But when you bring it in contact to each other, you can see that the charges, they get transferred. Okay, so that's how the transfer of charges work, and there is an electric field that is created surrounding the pith ball and the glass ball and the glass rod. Between the interface of the pith ball and the glass rod, there is an electric field that has been created. So what do we call the pith ball here? The pith ball has been called as a test charge. So how can we define electric field? You can define electric field as the force acting on a particular charge. What is the amount of force acting per unit test charge which is placed at that point? So appadi nama electric field oda or definition we can bring in. So adha nama ipo paakrom the module la. So listen carefully.
When placed within the electric field, the test charge will experience an electric force F. The strength of the field can be derived using the equation E is equal to F by Q, where E is the electric field strength, F is the force, and Q is the charge.
So this is the basic definition of electric field. So electric field basic equation vandu idudha. The force acting per unit test charge placed at a point is defined as the electric field surrounding that point. So idoda unit, electric field oda unit enava irukum? What will be the unit? Who can tell me the derived unit?
Newton per coulomb.
Yes, the derived unit vandu Newton per coulomb. It is a combination of two physical quantities, force and charge. So Newton divided by coulomb. So that is the unit of electric field. Good. So we are moving on.
An electric field can be diagrammatically represented with electric field lines indicating both the direction and strength of the field. Electric field lines begin at a positive charge and radiate outward. Conversely, they are directed radially inward toward a negative charge. The line will be denser around a higher charge and less dense around a weaker charge. When two similar charges approach, the lines will diverge. And when two opposite charges approach, the lines will converge towards the negative charge. In the case of an electric dipole, which consists of two separated point charges having the same magnitude but opposite charges, the electric field lines will be curved. They will extend from the positive to the negative charge. At any point on the line, the field created by the dipole will be tangent to the line at that point.
Okay, so we looked at what is the electric field lines surrounding the charges. For a positive charge, electric field lines for a negative charge, how the electric field lines are present. So the electric field lines are always radial to both positive and negative charges. If we radial, directions it is present, surrounding it throughout. So all points combine, it will look like a sphere. Okay, it will be spherical. Or a sphere represent all points. If you consider all the electric field points surrounding a positive or a negative charge, it would represent a spherical surface area. Okay, so that is what we understand. So over a positive charge, the electric field lines are radially inwards. It is towards it. Or is it outwards? For a positive charge, the electric field lines are going to be radially outwards. It is always present from the positive charge, it is moving away. But for a negative charge, it would be towards it. It would be radially inwards. Elena, you can say it is moving towards it. So this is the nature of the electric field lines surrounding two charges. So electric field strength represent it is based on the charge. Suppose I am having a charge of 5 coulombs. If electric field lines it will be little weaker. The same thing if I am having a charge of 500 coulombs. Now how will you represent the electric field lines? It is again radially outward, but the density of the field lines will be more. Adoda crowdness greater. If you are taking a greater magnitude, the higher the magnitude of the charge, the greater is the electric field lines surrounding it. So that is how you understand that the strength of the electric field lines surrounding the charges. The greater the magnitude of the charge, the greater is the electric field strength. The greater the strength, the greater will be the crowding of the electric field lines surrounding it. Okay, and the electric field at that point would be given as a tangent drawn to the electric field lines at that point. So it is represented using a tangent. So this is all about the electric field. Okay, so for the electric field, we are coming to the end of this module. So electric field so now we are moving on. So in the animation, they are showing you how the electric field from a positive charge is moving towards a negative charge. You have a system of two charges. So positive charge diverge. Negative charge you can see all the electric field lines are converging. So that is what you understand. Okay. So this is about the electric field. So that's about electric field. So for a positive and positive charge orientation where you will place the negative charge and where you will place the positive charge. We have to drop there. So first diagram it is getting diverged. So what would be the nature of charges for the first diagram?
Positive.
Yeah, both will be positive.
Yes, sir.
Excellent.
Yeah. Positive.
Excellent.
So both of them are positive. What about the second diagram? First one?
First one positive. Second one negative.
Excellent.
Yes.
Excellent.
So we can, this is a small activity. So based on namakku conceptual understanding test பண்றதுக்காக ஒரு small activity. Okay, so this is how the nature of charge. இதே வந்து நான் ரெண்டு negative charges வந்து பக்கத்துல கொண்டு வந்தேன்னா how would the diagram look like? What is the direction of electric field lines when I bring two negative charges close to each other? Yes. Positive madriye irukuma, will it be different like two positive charges? First diagram mariye will it be, or will it be a different than the first diagram? When I bring two negative charges close to each other?
So first diagram mariye.
Yeah. What about the direction?
Opposite irukku sir.
Ama. Correct. It will be opposite. Yena it is going to move towards the negative charges. Avladha. Rendu positive charges irunduchina divergent electric field da. They diverge away from each other. They do not intersect. Rendume meet agadu. But you can see the direction of electric field lines is going to be radially inwards when you have two negative charges. When there are two positive charges, divergent electric field and radially outward. That is the only difference. Okay, so we are moving on. So that is about it. Simple. So this is a concept map where you have everything. Okay, so all the points are there. So now we will move on to certain questions based on the electric field. Okay. Yes, so here is the first question. The force experienced by an alpha particle in an electric field of 1.5 into 10 power 4 newtons per coulomb is. So try solving the questions. Here is the first question. Try panna. Okay. Electric field kuduthirukanga, force kekranga. Electric field oda formula ennadu? You have to apply the formula.
F by Q.
Yes, E is equal to F by Q. So what is F? F is equal to Q into E. Rearrange panninga appadina. So rearrange panni, substitute the values and then find out. So what is alpha particle? Positively charged particles are your alpha particles. Yeah. Charge of a proton ninga eduthikalam for alpha particle 1.6 into 10 power plus 1.6 into 10 power minus 19 coulombs eduthikalam. Okay, yeah, so solve panni solunga.
None of them.
None of them? No, it's not none of the above. Usually it is 1.6 into 10 raised to minus 19. 4.8 solranga. But inga substitute panningena, I think 1.5 into, so plus 4 and minus 19. When charges one, you have 10 raised to minus 19. Yeah? So minus 19 plus 4. I think obviously you would be getting minus 15, isn't it? So minus 15 they have not given here any range. And I think they are not considering a protonic charge. So I think they are taking a different charge. Okay, for 4.8. Usually we take it as 1.6 into 10 raised to minus 19 for alpha particles. Okay. So the charge. So we'll go to the next one. That is the idea. The electric field produced by the electric charge of 1 coulomb at point O. What is the electric field produced by the electric charge of 1 coulomb at point O? Point O la vandu, what is the electric field due to the electric charge?
9 into 10 power 9. C option.
9 into 10 power 9. Okay. Yes, it is 9 into 10 power 9. This was quite easy. So, this is again based on the concept. So, we have learned what is the relation between electric field and the electric forces. Okay. Okay, next question. If electric potential at a point x comma y in the xy plane where this is a function minus kxy. Okay, what is the electric field accelerated starting from rest to acquire a speed of 10 meters per second? So the speed is 10 meters per second. So they are asking what will be the electric field.
Option D.
Option D. Okay, என்ன பண்ணீங்க?
I just guessed, sir.
You just guessed. You should have some explanation. Don't go for a guessing work. How did you try it at least? Okay, even for guessing also you need to try something. So how did you try it?
Sir, rest to acquire a speed of 10 ms power minus 1 கொடுத்திருக்காங்க sir. அப்போ அத 2 ஆல 2 ஆல டிவைட் பண்ணி பாருங்க sir. 5 வந்தது sir.
Okay.
அப்போ 5 into 2 பண்ணா நமக்கு வந்து 10 கிடைக்கும் sir. அப்போ அந்த 2 அப்போ 2 னு கன்ஃபார்ம் ஆச்சு sir. அப்போ r ஸ்கொயர் அப்போ ரெஸ்ட்ல கொடுத்திருக்காங்க. ஃபார்முலால நம்ம அப்ளை பண்ணும்போது r ஸ்கொயர் அப்படினு நமக்கு வேல்யூ கிடைச்சதுன்னு அந்த மாதிரி யோசிச்சோம் sir.
Okay, r square, fine. Sure. So, we are representing, they have told you that it is a point in the xy plane. So, electric potential at a point, so you are marking that point. This is the first quadrant, it is lying. So, first quadrant, it is at points or some distance x from the x-axis and y from the y-axis. So, you have to find out what is the resultant of this corresponding vector notation. So resultant of vector நமக்கு எல்லாருக்குமே தெரிஞ்சதுதான் parallelogram law of vector addition யூஸ் பண்ணி you have to get the resultant. அப்பதான் resultant electric field நமக்கு கிடைக்கும். ஏன்னா position vector தான் கொடுத்திருக்காங்க இங்க. So what will be the resultant? Under root of x square plus y square ன்னு வரும் இல்லையா? Because you are taking the xy plane. So that will be the resultant of the electric potential vector at that point. So you find the resultant and then you go and substitute the value. So v is equal to minus kxy is what they are represented. So minus kxy substitute பண்ணீங்க அப்படினா so it is k square times x square plus y square. So அந்த மாதிரி you will get the relationship. So finally நீங்க அதை simplify பண்ணீங்க அப்படினா because both of them are at equal distances, so you can substitute. We know that x square plus y square is equal to r square. So அந்த polar form வந்து நம்ம யூஸ் பண்ணி தான் we are substituting. சரிங்களா? So it is r. The answer is r, not r square. ஏன்னா square root ல இருந்து நீங்க வெளியில எடுக்கும்போது அது வந்து r square வராது, r தான் வெளியில வரும். So you are almost right, but you need to take a square root. சரிங்களா? So it is actually r. So electric field is proportional to the r. Okay. This is a different way of approaching. Okay, intensity la nama paakla, we will see intensity. So whichever we have learned, we will do it. And this you can try. The electric field E due to a charge Q is. So what is the electric field due to a charge Q? 4 options are there.
B option.
Yes, it is B. It is independent of the test charge Q and dependent on the space coordinate R. So the electric field due to a certain charge Q na, so it is independent. You are not considering that the test charge. It's basically based on the other charges. You are studying at that particular point. அங்க ஒரு சார்ஜ் இருக்கிற மாதிரி நம்ம வந்து அதை ஸ்டடி பண்றோம். We are only studying the electric field at that point due to other charges, due to the system of other charges, not the test charge. Okay, so it is independent of test charge q and dependent on the space coordinate. Of course, the distance it is dependent on. So the answer is option D. Okay, dimensional formula for electric field. Newton per coulomb அப்படிங்கிறது உங்களுக்கு தெரிஞ்சதுதான். So how can we represent that Newton per coulomb in terms of dimensional formula? So Newton na force oda unit. So 1 Newton வந்து 1 kilogram meter per second square. அதே மாதிரி coulomb na in terms of current also you can represent. Q is equal to IT இல்லையா, current into time. A option வருதா? Okay.
Option A sir.
Option A. சரி. No, it is not option A.
Option B, sir.
Option B. Okay. So I'll try to understand what you are doing. So Newton per coulomb.
Option C.
Okay, so many multiple options. One second, we will just work it out. So Newton per coulomb, isn't it? So you write it as n upon. So I'll go to the blackboard. Just 1 minute. We cannot annotate so much. Okay, நான் ஷேர் பண்றேன் blackboard. Just let me know. திரும்பி I am resharing. Yeah. So எல்லாராலையும் பார்க்க முடியுதா blackboard? I hope it's visible.
Yes, sir.
Okay. So dimensional formula is what they have asked, isn't it? So dimensional formula when they ask, first வந்து நம்ம formula எழுதிக்கலாம். Formula எழுதி you bring the units, proper units. So the electric field formula is F upon Q, isn't it? This is what we have. So force வந்து is newtons and Q is in coulombs. அதனால தான் நமக்கு newtons per coulomb கிடைச்சது. So now we represent newtons per coulomb in terms of dimensional formula. So 1 Newton is equal to 1 kilogram meters per second square, isn't it? So these are the dimension first எழுதுங்க. So what is the dimension of this? Kilogram na mass, apro meters na length, second square.
L T power minus 2. So.
Yes, ml T power minus 2. So அது Newton எழுதியாச்சு. அதே மாதிரி 1 coulomb கூட எழுதணும். So coulomb is charge Q. Okay, so Q is equal to current into time. So I into T. So current வந்து the unit for current is amperes. இல்லையா? And for time வந்து seconds. So time T தான். So A into T. So what would be the complete dimensional formula? So multiply both. So M L T power minus 2 into T. வந்து T power minus 1 வரும் into A. So you will get M L T power minus 1 into A. சரிங்களா? So அது வந்து அதுதான், that is what is the answer.
Sir, A power minus 1 தான் sir.
One second. A power
Coulomb divided by
-1.
I is equal to, let me check, Q divided by T. Cross multiply தான பண்றோம். -1 எப்படி வருது? Okay, கீழ நம்ம substitute பண்ணோம். Divided by. Okay.
Sir, F is equal to E.
Yes, we are dividing it. Newton by Coulomb, yeah, we should not multiply, isn't it? We are dividing. We are dividing these two values. Correct. So mLT power -2. ஏன்னா Coulomb வந்து Newton வந்து மேல இருக்கு, Coulomb வந்து கீழ இருக்கு. சரி, நான் டிவைட் பண்ண I multiplied by -3.
-3, sir.
Yeah. So அப்போ என்ன ஆகும்? You will get mLT power -3 and A power -1. Is this correct? So you will get like this. Yeah.
Yes, sir.
This is what we will get. Yes. So this is the answer. So இதோட option பாத்தீங்கன்னா அங்க வந்து the option is different.
B.
Yeah, it was B option. நம்ம A ன்னு சொல்லிருந்தீங்க. That's why I corrected. Sure. So it is option B. Okay. Okay. So we will solve some questions also. So some standard questions. So let me finish off this chapter. So we just left with small part. Gauss theorem அப்படின்னு சொல்லி ஒன்று இருக்கு. We'll finish that and then we'll go to all the questions. Let me again share the screen. பாருங்க திரும்பி ஷேர் பண்றேன். ஸோ அந்த ஆன்சர் வந்து ஆப்ஷன் பி. சரிங்களா? ஸோ பி தான் கரெக்ட் ஆன்சர். ஓகே, ஸோ வில் கோ டு நவ் தி நெக்ஸ்ட் மாட்யூல். So electric field, I hope the concept is clear. எல்லாத்துக்குமே next we will go to electric field lines and eventually electric flux பார்த்துடலாம். Okay.
Electric field lines and electric flux.
Okay. So audio வந்து audible இருக்குங்களா? I hope you're able to hear.
Yes, sir.
Okay.
We know that a charge produces an electric field around itself. But does the strength of the electric field vary with distance? This animation will throw more light on the electric field due to a positive charge. This translucent sphere portrays the electric field around a positive point charge. Here's a two-dimensional representation of this electric field. The electric field intensity at a point decreases inversely as the square of the distance of that point from the charge. This is indicated through the length of the arrows. Observe that the outward arrows get shorter as they move away from the positive charge.
Okay, so இங்க என்ன சொல்ல வராங்க? Electric field வந்து when you represent across a charge, அதோட intensity இல்லனா அதோட magnitude வந்து நம்ம தூரம், when you're trying to go away from the charge, what's happening to the electric field intensity? Is it increasing or is it decreasing as per the module? So we understand it decreases. Inverse square law da. It is again obeying the inverse square law. As you're going away, so the electric field intensity is going to decrease as you go away from the charge, because you are going away from the region of electric field. So adanal they have used the arrow mark notation. So the arrow marks close to the positive charges, they are bigger in size than the arrow marks which are away from them. So they are shorter. So what do they literally mean? They mean that the electric field intensity closer, to the charge, would be greater. That is, electric field intensity is more as you are close to the charge, and as you move away from the charge, the electric field intensity is going to decrease, or it's going to eventually reduce. Okay, so that is the idea. So obviously, it's dependent on the distance. So we'll continue.
Now, let us connect the aligned multiple arrows by a single arrow. The resultant arrow is known as a field line. Now, the electric field strength is portrayed by the density of the field lines. Electric field lines are closer near the charge. which means the electric field is stronger there. Likewise, as we move away from the charge, the electric field lines are more apart, indicating that the electric field is weaker in that region. You may...
So electric field lines வந்து நம்ம as you move away அவங்க என்ன சொல்றாங்க, it is reduced. It is therefore not that crowded. So where it is more crowded, நம்ம ஒரு circle வந்து ரொம்ப close to the positive charge நம்ம வரைஞ்சோம் அப்படின்னா it is very closer. They are crowded. Greater the crowdedness of the electric field lines, greater is the electric field intensity at that point. Lesser is the crowdedness, lesser would be the electric field intensity at that point. Okay, I hope that is clear. So that is the electric field intensity due to the charges. The positive charge is what we are seeing. இதே வந்து நெகட்டிவ் சார்ஜுக்கு நம்ம ஸ்டடி பண்ணோம் அப்படின்னா the arrow mark வந்து நம்ம இன்வெர்ட் பண்ண வேண்டியதுதான். It will be moving towards the negative charge. Okay, so this is all about it. So let's now move on.
You may draw more number of lines, but the electric field intensity is dependent only on the relative density of field lines. Simply speaking, the electric field at a point is relatively stronger if the field lines are more crowded near an area under consideration. The electric field lines are more crowded near a charge compared to a region away from the charge, indicating that the electric field intensity decreases as we move away from the charge.
Okay, so electric field intensity will decrease as you move away. The relative crowdedness is very, very less, but electric field intensity is more as you move towards the charge because the relative crowdedness of electric field lines is greater. So that is the concept that we learned in this module. Sherry, we'll go to the next one.
Let's now try to represent mathematically the relationship between the density of field lines and the electric field intensity. Consider a positive charge placed at point O. Consider 2 points Q1 and Q2 that are located at distances R1 and R2 respectively from the point O. Let's take the cross-sectional area of the plane that is perpendicular to the field lines at the point Q1. Let's represent this area element by A1. A1 subtends a solid angle delta omega at point O. Similarly, we take another area element A2 at point Q2, subtending the same solid angle delta omega at point O. Note that the number of field lines, say n, remains identical within the solid angle cone. The area of element A1 is given by the following equation. Similarly, the area of element A2 is given by this equation.
So inge vandu they are representing the electric field lines from a positive charge in a particular quadrant. Or quadrant eduthu nama study pandrom. So the number of electric field lines passing through the regions Q1 and Q2 vandu they remain constant. But what is changing as you go away? You can see that area element A2 is sweeping out a greater area. But the area element A1 vandu adoda area pathina kammi dhaan. In lesser area, you have more electric lines of force that are passing. So in the number of electric lines of force passing per unit area, you call that as electric flux. Nama adha electric flux nu solrom. Okay. So inge vandu we are trying to introduce the concept of electric flux. So what do you mean by electric flux? It is defined as the number of electric field lines passing per unit area. So now you tell me, நீங்க சொல்லுங்க இந்த ஒரு diagram பார்த்து where do you have a greater electric flux? Is it through A2 or is it through A1? Where there is a greater electric flux?
A1, sir.
It is through A1. Why is it A1?
Sir, density.
Why is it A1? Number of electric field lines are constant for both A1 and A2, but still why do you say it is A1?
So crowded. More area, more number of magnetic fields.
Exactly. The crowdness is more. அதுதான் நம்ம பார்க்கிறோம். A2ல வந்து crowd வந்து கம்மி. A1 compare panracha, we see that A2 is having a lesser crowd, but A1 has got a greater crowding of electric lines of force. So obviously electric flux density in another electric flux magnitude would be greater at A1 than region A2. So that is what we try to understand. That is what the module is also explaining. Seri, idu full paathirala.
Since the number of field lines passing through areas A1 and A2 are both equal to n, we may wrongly interpret that electric fields are equal at A1 and A2. To circumvent this problem, we compute the electric field lines passing per unit area element at Q1 and Q2 as follows. Note that the number of field lines n and the solid angle delta omega are the same in both the expressions. Thus, we can clearly see that the electric field strength varies inversely with the square of the distance from the charge.
So distance of the charge is a basic criteria for us to compute the electric flux or the electric field strength. Okay, so the lesser the distance, the electric field is going to be much greater. The greater the distance, electric field will be lesser. அதனால தான் நம்ம அதை inverse relationship னு சொல்றோம். ஒரு quantity decrease ஆகும்போது the other quantity will increase. இல்லையா? That is what is the basis of inverse relationship. Okay, so electric field and the distance of the charge from that point, they are inversely related to each other. Okay, so moving on. So அடுத்து இதுக்கு போலாம். The next module.
However, in real life, it is not possible to count the number of field lines passing per unit area. Moreover, the cross-sectional area element may be at an angle to the field lines or even parallel to the field lines.
This is also important. இப்போ நம்ம ஸ்டடி பண்ற அந்த எலக்ட்ரிக் ஃபீல்ட் at that particular area அப்படினு சொல்லும்போது அந்த area element கூட நம்ம கன்சிடர் பண்ணணும். So you need to consider it whether the area vector is lying in the direction of electric field. ரெண்டுமே சேமா இருந்து ஓவர்லாப் ஆச்சு அப்படின்னா obviously angle theta is going to be 0 ஏன்னா they are overlapping or rather they are parallel. So when they are parallel, there is no angle. The angle is 0. But when they are having some angle, acute angle அப்படினு பாத்தீங்க அப்படின்னா, so there is some angle theta. So it can be at right angles also, where theta can be 90. Acute na obviously between 0 and 90. So on the mari it can vary. Linear also it can be. Okay. So that depends on the angle also.
How then do we measure the strength of the electric field? We can find a solution to this impasse by defining two new quantities, the area element vector and the electric flux. We associate a vector to a surface area, which we call the area vector. The magnitude of this vector is the area of the surface, and the direction of the vector is along the normal to the surface.
Normal அப்படினா என்னது? What do you mean by normal to the surface? இது நீங்க Yes?
Perpendicular line.
Very good. It is perpendicular. Yeah, so it is perpendicular. Whenever you take an area element, இங்க ஒரு small square area element எடுத்திருக்காங்க. So to a small square plate, what would be the area element? It was going to be perpendicular from the center of axis of the square. Okay, or the center of mass of the square. What is the point of center of mass for the square? The point of concurrency of the diagonals of the square. Yeah, so where the diagonals of the square meet. So there the center of mass of the square lies. ஏன்னா நம்ம ஒரு symmetric element தான் நம்ம இப்போ கன்சிடர் பண்ணிக்கிறோம். For non-symmetric element, center of mass obviously would vary. Okay, it will change the position. So for the symmetric object, center of mass will be at the geometric center of that object. So ஒரு equilateral triangle எடுத்துக்கிட்டீங்க அப்படின்னா point of concurrency of the medians of the triangle எடுத்துக்கலாம். So if it is going to be a square, point of concurrency of diagonals. Rectangle, again you can take point of concurrency of the diagonals of the rectangle. So on the mari you consider it. Sure. On the point the area element is going to be 90 degrees outward. That's the main concept. So the area vector is going to be mutually perpendicular and it is going to be outward. So that's you need to understand. Okay, that is the main concept. Sir, moving on.
but a plane surface will have normals in two different directions. So, to avoid confusion, we always consider the direction of the area vector for a closed surface to be along the outward normal. If the surface is curved, we divide the surface into small planar elements and we associate a vector to each of this area element, which we call the area element vector. As a convention, the area element vector points outward. We can now define the electric flux phi as the dot product of the electric field and the area element vector delta S.
So this is the representation of electric flux. So delta phi is the electric flux representation and the phi அப்படிங்கிறது தான் electric flux வந்து குறிக்குது. It is the denoting symbol. It is a dot product. இங்க வந்து vector dot product யூஸ் பண்றாங்க. நம்ம எல்லாருக்கும் தெரிஞ்சது தான் electric field vector plus அந்த area element கூட நம்ம vector தான். ஏன்னா அதுக்கு direction உண்டு. So அதனால நம்ம அதை vector quantities கீழ தான் நம்ம அதை represent பண்றோம். So a dot product of two vectors. இதுக்கு வந்து நீங்க dot product யூஸ் பண்ணி நீங்க simplify பண்ணீங்க அப்படின்னா what do you get? For example, vector A dot vector B is AB cos theta. அந்த ஒரு ரிலேஷன்ஷிப் தான் நம்ம இங்க யூஸ் பண்றோம். So vector E dot vector delta S. So ரெண்டுமே dot product தான். vector E வந்து electric field vector, but delta S பாத்தீங்கன்னா என்னது? It is the area vector which is normal to that area, surface area. So அதனால தான் delta S ன்னு சொல்றாங்க. So when you take the dot product of two vectors, அதை expand பண்ணீங்க அப்படின்னா what do you get?
Scalar product.
Yes. So you will get E into delta S into cos theta. அவ்வளவுதான். So now you can also find out for what angle theta will the electric flux be maximum. என்ன கண்டிஷன் தீட்டாவோட எந்த கண்டிஷனுக்கு உங்களுக்கு எலக்ட்ரிக் ஃப்ளக்ஸ் வந்து மேக்ஸிமமா இருக்கும் அப்படிங்கறது கூட
Zero.
for 0. Yes. ஏனா cosine function அப்படி இல்லனா cos theta ஓட values பாத்தீங்கன்னா it is ranging from 1 to 0 இல்லையா? cos 0 வந்து 1 ஆனா cos 90 பாத்தீங்கன்னா 0. So cos function ranges from 1 to 0. So for cos theta 0 you will have a maximum electric flux. So that is the condition. So on the trigonometric function வந்து base பண்ணி தான் you will have the magnitude or the maximum condition for electric flux. Okay, so that is how you understand. So what is theta? Theta is the angle between electric field and your area element vector or the delta S vector. Okay, so that is what is the idea. I hope you understood electric flux concept. So அடுத்த concept போலாமா? I hope this is clear. Yes, yeah. So நம்ம எல்லா modules பார்க்கும்போது நம்ம புது formulas encounter பண்ணும்போது it is a very good practice to write down the formulas. So ஒரு notebook வெச்சுக்கோங்க. ஒரு small one square notebook you can keep dedicatedly for formulas, 100 or 200 pages, chapter name heading போட்டுட்டு you can write all the formulas along with the units, SI units and the dimensional formula. It is very useful for competitive exams. Okay, so that you can have all the formulas at one place. Seri, so moving on.
This could be further written as follows, where theta is the angle between the electric field and the area element.
So now we are moving on to the next one.
Now, let's recapitulate what you have just learned in this animation.
So this is our complete summary of what we have learned. Okay. So the electric field intensity is dependent on the relative density of field lines. That is the number of electric field lines which are originating from that point or moving to that point. So that is the electric field intensity. Second point, the electric field strength varies inversely. Yes, as you move away from it, away from the charge, the electric field intensity will decrease. As you move closer to the charge, the electric field intensity is going to increase. That is what you understand. What is R? R is the distance from the test charge to the charge that you are studying. So R is the relative distance, the distance between the point and the charge that you wish to study. So that is R. And the third point, electric flux can be represented as a dot product of two vectors, electric field vector and the area vector. So when you try to represent the dot product or expand the dot product, the scalar dot product, you get E into delta S into cos theta. Okay, the formula is vector A dot vector B is AB cos theta. Same logic apply panni, we can get the relationship here also. And for theta is equal to 0 degrees, the electric flux will be maximum. That is also one more point additionally you can note. Okay, so with this we come to the end of electric flux. So now we move on to the next module. So this is the same thing only. Okay, this is also that we have already learned. We'll move on to the next one. Next one, the electric dipole. So we'll see electric dipole. Okay, let me reload the page. Okay, so in the module, a technical glitch, it's not loading. So I'll tell you what is an electric dipole. Okay, so electric dipole, it is nothing but the distance between two charges. So whenever I say a dipole means there is two polarities, one positive and you have a negative charge, which is separated by a distance of r in space. So you try to find out what is the resultant electric field due to those two systems of charges. So the electric dipole. So it is nothing but the distance, the electric field due to two charges which are equal in magnitude but opposite in their directions. When they are separated by a distance of r in space, the resultant electric field due to both the charges, you call them as an electric dipole. So that's the field of an electric dipole, basically. Okay, that is the basic idea. So we don't have any formulas for that. That's just a small concept. So next we'll go to the important part, the charge distributions.
Continuous charge distribution. We know that electric charge is quantized. The smallest quanta of charge can exist as either positive E, which is the charge on a proton, or negative E, which is the charge on an electron. So, a charged body basically consists of many discrete charges with magnitude E. To determine the electric field at a point due to a charged body, it would be impractical to work in terms of discrete charges present at the microscopic level. For example, even 1 microcoulomb of charge will contain over 10 to the power 13 quanta of charge. In such situations, we divide the charged body into small elements. Next, we find the electric field generated by these individual elements at the given point, and then add them to find the net electric field. There are 3 types of continuous charge distribution: linear charge distribution, surface charge distribution, and volume charge distribution.
So we have charge distribution. You have different types. 3 different types of charge distributions are there. First one is linear charge distribution. So we will see how it is. Linear, obviously like a straight small wire and a thin element. So you can consider that as linear charge distribution. Surface with respect to 2 dimensions. Linear, you can take 1 dimension, either only length. Surface charge distribution, both length and breadth you will consider. Volume, you will additionally consider the third dimension, x, y, and z axis. So obviously you will have length, breadth, and height also. So on the money, we have three different types of charge distribution. Okay. So based on this, you have formulas. You'll see it.
In a linear charge distribution, the charges are distributed along a line. An example of such a distribution is a uniformly charged metal wire. In a linear charge distribution, we consider a small line element of length delta L, containing the charge delta Q. The linear charge density, lambda in this case, is defined as charge per unit length. The unit of linear charge density is coulomb per meter. The second type of charge distribution is where the charges are distributed over an area. Such a charge distribution is called surface charge distribution. An example of such a distribution is that of a charge sheet. To calculate surface charge distribution, we first divide the area into small equal surface elements, delta S. The charge contained in each surface element is denoted by delta Q. Then the surface charge density, sigma, can be defined as the charge per unit area. The unit of surface charge density is coulomb per meter square. The third type of charge distribution is the volume charge distribution. In such a type of charge distribution, the charges are distributed over a volume like that of a sphere or a cube. For a volume charge distribution like that of a charged solid body, we consider small equal volume elements, delta V. The charge contained in each volume element is denoted by delta Q. The volume charge density, ρ, is defined as the charge per unit volume. The unit of volume charge density is coulomb per meter cube.
Okay, so here we saw different types of charge distributions. So linear charge distribution, surface charge distribution, adukaprom we saw volume. So inge vandu there are certain important things that you should know. Linear charge distribution now the distribution of charge with respect to a unit length, yeah. So charge per unit length. This is your linear charge distribution. Surface charge, again charge per unit area. For volume, we talk about charge per unit volume. So that's it. So that's about the different types of charge distributions that we need to know. So based on the charge distributions, now we have certain aspects. So we have relationships that we need to be knowing. Okay, so based on that, so we have different methods of getting the relationship. So I'll go to the blackboard and I'll explain. So now from here on, we have certain theoretical concepts. Derivations are there. So we will see the relationships and then we will move on. Okay, so let me bring in. Yeah, now I'm sharing the blackboard. So solunga ungala blackboard paaka mudiyudha appadina. Okay. Yes, you're able to see the blackboard. Okay. Yes.
Yes, sir. Visible.
Okay, visible. So now we will see the whatever we have learned. Quicker nama formulas paathu. We'll see the formulas and then we'll proceed further. So what will be, how we'll proceed further of what we'll be relating all the quantities together. So first, we have also learned electric flux today in today's lecture. So the electric flux is given by delta phi. So first I'll just write down. So we learned about electric flux today. So what do you mean by the electric flux? Isn't it? So electric flux through a particular given area. So the term electric flux means in a given area would give you the electric field and the total number of electric lines of force passing through that area. So we can simply say it is the dot product of the electric field and the area element. So E bar dot delta S. So simply you can say delta phi, the electric flux delta phi E is nothing but the dot product of two vectors. So you can write it as E into delta S into cos theta. And when is it maximum? It's maximum when there is a condition. What was the condition we saw?
Theta equal to 0 degree.
Yeah, when theta is equal to 0 degrees, we see that the electric flux is going to be maximum. Okay. Yes. So, what is the unit of electric flux? The standard SI unit. So, we are going to first write down. For electric field, you know it is Newton per coulomb, wherein for area, it is going to be meter square. So, combining both, what would be the SI unit of electric flux?
Newton meter square. Newton per coulomb.
Yes, the SI unit for electric flux is, so we write that as Newton meter square upon coulomb. So this is the unit of the SI unit of electric flux. So this is one aspect of it. Okay, so once you have found out the electric flux, next we also saw the different types of charge distributions now in the recent slide. So the different types of charge distributions, we saw what is a linear charge distribution, we saw what is an aerial charge distribution, so on and so forth. Isn't it? So that is what we saw. Okay. So what do you mean by a linear charge distribution? Yes. Anybody? What is a linear charge distribution?
Charges distributed along a straight line.
Okay, along a straight line. Yes. So first one, in charge distribution, you have three different categories. First one is linear charge distribution. So in this linear charge distribution, we can represent this linear charge distribution using, an alphabet. So general representation I will teach you. So we represent linear charge distribution as lambda, which is the charge per unit length. Okay, so change in the charge is delta Q upon delta L. So this is lambda. Okay. So charge varying per unit length, you call that as a linear charge distribution. So Adhe Mari, how can we represent the area? Second one is the area charge distribution or surface charge distribution.
Q by A.
Yeah, it is Q upon A. That's correct. So we represent the surface charge distribution using a representation. Okay. So here we use a representation as sigma. So sigma is equal to Q upon A. So charge per unit area or change in the charges per unit area. Per unit change in area. So for the variable charges. So we can represent like this. This is for the surface charge distribution. And third, last but not the least, we have volume charge distribution. So how do we represent this quantity?
Rho.
Yeah, so we can represent using rho, where rho is the charge per unit volume. So it is again delta Q upon delta V. Now the SI units we will write simultaneously, side by side. The first one for the linear charge distribution, what will be the SI unit? It would be coulomb per meter. The second one, it is going to be coulomb per meter square. It is the area that you're talking about. The third one, it is going to be coulombs per meter cube. So these are the units for all the three different types of charge distributions that we need to be known. So this is one important aspect. Okay. So once you have all the charge distributions, so now we go and we relate and we try to find out what is the electric field and so on and so forth. So we try to find out what is the electric field at different types of configurations you can find out. So before that, the electric dipole, the module was not working there. So we will see the electric dipole concept before we proceed any further. So we will see that also. Okay, electric dipole concept also we will see. Okay. So now we are in the continuous charge distribution. So now let us see what is the charge distribution for the different types of objects. Okay. So we will take different objects. For example, let's take a spherical object and we try to understand what is the different types of, what is the charge distribution for the sphere. Okay, so we will try to understand that. First one. So we will see if you have a charge, so say if a charge is distributed if a charge is say distributed over a sphere, okay, then what do we represent? You know that sphere is a three-dimensional object. So what type of charge distribution would be more apt to represent if you take a sphere? Because it is a three-dimensional object, obviously you talk about volume, isn't it? So I'm going to take a very small, first you represent the entire sphere. In this sphere, you can represent the smaller part. You can take a small volume element, so which is also three-dimensional, and we represent the corresponding aerial vector, which is normal to the surface. Okay, so the area vector is there. The distance is, you can take it as r bar, and I am placing a test charge. Say the test charge is q naught at that point, and the entire volume of the sphere is v. So we can represent this in terms of the volume charge distribution. So this comes under volume charge distribution. So where we can use the representation as rho is equal to volume charge distribution formula we apply, where rho is equal to q upon v. So what is q here? So here appropriately q is the charge distributed over the entire sphere. So in the sphere you have the charges which are uniformly distributed. So adha q nama eludikrom. So it is distributed, so it is q upon, what is the volume of a sphere? Formula? Who knows the formula for volume of a sphere?
4 by 3.
Yes, it is 4 by 3 pi r cube. So okay, so 4 by 3 pi r cube. The units you should not forget, it is coulombs per meter cube. So in the Mari, you can get the relationship for the charges. Okay. So in the Mari, now we found out the relationship between the volume charge distribution. Now what is our necessity? We would like to find out the electric field due to this charge q naught, on this q naught at a distance of r in the sphere. Okay. So we wish to find out what is the electric field. So now you go for a simple rearrangement. Okay. So you know that first formula was this. Rho is equal to q upon v. So what is q? Q can be written as rho into v. Okay. Next I am differentiating on both sides. So I am differentiating on both the sides. So when I differentiate on both sides, I am going to express the differential operator. dq will be equal to rho. Now rho is constant. So rho is nothing but the density, volume charge density. Density will remain constant. It will not change. But volume can change. The sphere can be, the region can be a smaller or a bigger region. Yes, of course. So we can write dq is equal to rho into dv. So this is how I bring the relationship. Okay. So dv is nothing but the change in volume. So now first we wish to find out what is the force experienced by the test charge q naught at a distance of r. So you find out that first. So apply the formula. What is the formula? F is equal to, what is the relation between force and electric field? F is equal to q into E, right? Charge into electric field, then that is the formula, isn't it?
Yes, sir.
Yeah, I am applying that now. So F is equal to q into E, but formula for E, electric field itself, electric field or formula there is in terms of charges, in terms of the test charge, in terms of just the charge, k into, do you remember the formula? Kq by r, or is it kq by r square?
R square.
Yeah, it is kq by r square. This is one formula. Electric field is kq by r square. K 9 into 10 power 9. Usually we take that value. Q is nothing but the charge distributed over the sphere in this case. So nama ipo poi substitute pannalam. But now what we are doing, because you have the volume being changing. So we are going to now integrate on both the sides because it is changing. The dq is equal to rho into dv. So we are applying a differential operator. We try to find out what is the charge when the volume is also changing. So apo you are going to express in terms of a differential operator. Okay. So now I am going and expressing this. So F is equal to, now I am going to express this. So E is equal to, so I can go and substitute the value in terms of test charge, but it is nothing but K Q naught by upon R square. So I am substituting that. So K times Q naught upon R square, okay, into our Q. So dq is nothing but rho into dv. So we already know that. Okay. So I am substituting that also. So I am substituting that, and now you can see namakku vandu oru integrating factor kedachirukku. The factor of integration is there. So we have a factor of integration. So I go ahead and now I integrate. I wanted the force due to all the area elements, not just one element, all the elements. So appo nama integrate pannida. So we need to integrate around the complete sphere. So what you do, take the constants outside. Q naught is a constant, K is a constant. Okay, so I remove both the constants out of the integration sign. Let me just write down K times Q naught. Okay, now you apply the integral sign. So integration V times, now what is the rho? Already we have calculated the rho value as dq upon dv. So that is a relationship. So already rho is nothing but q upon 4 by 3 pi r cubed. So we have the relationship here. Okay, now we are only generalizing. You need not go and substitute that. You just generalize it. So r square can be taken inside. R is nothing but the distance. So that is going to be a factor that changes. So rho upon r square into dv. So we get the relationship like this. So this is the force experienced by any charge on a particular volume distribution. So for a three-dimensional object, what is the force experienced by the charge is this. So in the mari we represent. Okay, into additional area element oda vector kuda neenga represent pannikalam. So here I have represented the position vector as r bar. So adoda unit normal position vector vandu r cap nu solluvom. So adha kuda neenga represent pannikalam. So this is force. We got the force. Now you can also find out the electric field also. So in terms of electric field, you write E is equal to F upon Q. Okay, here the test charge is Q naught. So I write it as Q naught. That's equal to, again you substitute K vandu you can keep it out. Integration along the volume. So integral V. Now rho upon, now what do you get when you divide by Q naught? So appropriately rho times, again same representation, right, for F, R square into D. So you can see that test charge Q naught, anga irundha Q naught inge vandu cancel aayidum. Dividing by Q naught, isn't it? So the Q naught term would go away. So for electric field, the formula is K times the integral value of the volume charge density upon R square into dV. This is the electric field relationship for the volume. When you take a three-dimensional region, nama in the formulas nama use pannikalam to find out electric field and to find out what is the force. Okay, so we will be applying this in real time and we are going to get so many relationships. Okay, this is for the three-dimensional objects we can apply. Adhe mari nama vandu surface ko nama derive pannikalam. Even also we can derive for the linear also, linear regions also. Okay, for surface charge, next we will see surface. For surface charge distributions, nama enna relationship nama paathom slide la. We saw surface charge distributions as we took sigma, isn't it? Where sigma is equal to the charge upon unit area. So adha vandu dq by da nu eludikalam. Change in charge per unit, change in area. So we can represent, and obviously not forget the units. It is going to be coulomb per meter square. So that was the SI unit for the surface charge density. So ipdi nama eludikalam. When you represent like this, now again when you talk about a surface, so it can be any surface. So randomly I am taking one surface. So you take a particular point on that surface. and you can see the charges evenly distributed along the surface. So you can show the charges here, even distribution of charges along the surface. Now represent the vector. So I'm taking a point Q naught away from it, that where Q naught is my test charge. Don't forget, Q naught is the test charge at that point, and say R bar is nothing but a position vector, or representing the distance between the test charge from the surface charge distribution. Okay, so what would be the surface charge distribution dq here? How can we write dq? Go for a rearrangement, sigma into dA. I'm just rearranging. Okay, so we can represent the mari nama represent panikalam. Adhe mari ipo nama force kandupidichukalam. What will be the force experienced by the test charge at that point away from the surface charge distribution? Same way we can write k into q naught integral. Here you have to take the surface, surface sigma upon r square into ds. Anga dv eduthutom, inga ds eduthukom, avladha. This is nothing but the surface. So surface we are taking ds, where ds is nothing but the change in surface. Simple. So we can find out what is the force. Same way you can also find out what is the electric field also at the surface. For electric field, what will happen? Only the Q naught term will go away, others will remain. So because ES is equal to Fs upon Q naught, isn't it? This is a formula. So don't you think the Q naught will get cancelled? Yeah, so you will get K, again integral S, sigma upon R square into ds. That's it. So like this you can find out the electric field for surfaces. In general you can use this. எந்த ஒரு சர்ஃபேஸ் கொடுத்தாலுமே நம்ம ஜெனரலா இந்த ஃபார்முலா யூஸ் பண்ணி நம்ம வேல்யூஸ் கண்டுபிடிச்சுக்கலாம். ஸோ தட் வே திஸ் இஸ் வெரி யூஸ்ஃபுல். இப்போ நம்ம எதுக்கு இன்டிகிரேட் பண்றோம்? why are we bringing in calculus here? What is the relation between integrating? Because you want to cover the entire surface. ஸோ நம்ம ஒரு சின்ன ஸ்ட்ரிப் எடுத்து எல்லா ஸ்ட்ரிப்ஸையுமே நம்ம ஆட் பண்றோம். So thereby when you integrate, it is basically you are summing up the total area you are covering. That is why you go for integration. So integration is a calculus operator in maths where you can add up all the regions and you will get the total region, the area of total region or the volume of total region. Depends on what you are integrating. Here I am integrating the surface, so I will get the surface, total surface area. Previously I am integrating the volume. So ஒரு சின்ன ஸ்லைஸ் எடுத்துட்டு எல்லா ஸ்லைஸுமே நம்ம ஆட் பண்றோம். ஸோ ஃபுல் ஸ்லைசஸ் நம்ம ஃபார் எக்ஸாம்பிள் நீங்க கேக் எடுத்துக்கலாம். கேக் இஸ் a 3D, right? The cake which we eat, which we get in bakery. So ஒரு சின்ன piece of cake when you take it, so how does that cake look? The cake is 3-dimensional. It is having a solid angle. So அந்த மாதிரி எல்லா பீசஸுமே நீங்க ஆட் பண்ணீங்கன்னா you will get the total volume of the cake, isn't it? If you take one volume and then you are going to add many such pieces symmetrically, eventually you will end up getting the volume of the cake. The same way here for area also you take a small slice and therefore you add in everything. So that's the integration of ds. So don't get confused. Okay. Sorry. Next one we are moving for the linear distribution. Okay, for the linear charge distribution. So linear distribution, how do we represent? So for linear distribution, yeah, so we represent using lambda. So where lambda is equal to dq upon dl, right? Charge per unit length, or just q upon l, both are same. So this is for linear charge distribution. Obviously the SI units would be coulombs per meter for this. இப்போ இங்க வந்து நம்ம ஒரு சின்ன wire எடுத்துக்கலாம். So wire has got a uniform charge distribution like this. So it has got a uniform charge distribution. So inge vandu you take a very small element. So this element only is called as dl. Okay, and totally if you add you will get the entire thing. So in the or element la irundhu we wish to find out what is the force acting on a test charge placed at a distance of r bar. Position vector vandu r bar. So again we find out what would be the force experienced due to the linear element. It would be F is equal to K into Q naught. திரும்பியுமே you integrate the entire length. இங்க length integrate பண்ணுவோம், அவ்வளவுதான். Lambda upon திரும்பி r square into this, it will not be ds, it will not be dv, it will be dl. Okay, that's all. So this is a force. Same way, what is the electric field due to that linear element L? We can write it as FL divided by Q naught. Q naught will get cancelled off. Finally, you will get K times integration of L lambda upon R square into dl. That's all. So this is the electric field. So like this, we can write down the expressions for both the force and the electric fields. Okay, simple. So in the Mari, we can get all the relationships. Okay, Seri. So either way, for example, if we are going to the Neet level questions. So I am having a wire that is infinitely extending on both the directions. In the side mein. Here it is plus infinity. Here it is minus infinity. My question is, what is the electric field? Okay, what is the electric field due to a point Q naught at the point, exactly at the midpoint of this wire? What is the electric field due to Q naught placed at the midpoint of this wire that is infinitely extending on both the directions? Again, a small element, you take this element as small element as dx. It is along the x-axis, it is varying. Okay, so we take it as dx. So with respect to this point, you try to find out what is the electric field at Q naught. So you study what is the electric field. So how can you find out the electric field at that point? Q naught due to the small element dx. It is also going to be a small electric field, isn't it? So it will experience a smaller electric field. In which direction? Because you place a unit test charge Q naught, you know that like charges are going to repel each other. So electric field will be in this direction, isn't it? So you call it as dE. Okay, it is dE. So now if this angle is theta, this is theta. So we don't know the angle, we are generalizing. Okay. So if this is theta, what else is going to be theta? Appropriately, you can take this also as theta. If not this, you can take this also. If this is angle theta, so you extend pannunga. You know that vertically opposite angles are equal. This angle is also going to be theta. Resolution of vectors. Vectors and the vector D you resolve pannala. It has got two components. One is vertical component, another horizontal component. So what is EY? Vertical component here, it is DE cos theta, resolution of vectors. Adhe mari horizontal component will be DE cos of 90 minus theta. 90 minus theta sin theta nu eludikalam. So you will get it as DE sin theta. Okay, so you can represent like this. Adukaprom next you can go for a electric field representation. What is electric field? This comes under a linear charge distribution. It is a wire. Linear charge distribution, we can use this formula, isn't it? This relationship can be used. Electric field EL is equal to K into, so integrate from L lambda upon R square into dl. You can apply that. So E is equal to, so substitute that value. Integration L times lambda upon R square into dl. So we need to apply this. Inga electric field is due to a small element. So you can write E as dE. You can represent E as dE. So due to a small electric field, dE can be written as K times, okay, so lambda into, appropriately you can write along the length. So lambda upon R square into dl. So because you are finding out a small, due to the small element dx, we are finding out a small electric field that it is experiencing. So we can write it as dE. Then you go for representation. So for R square, what is the R square value? Where is the figure? Yeah, here is my figure. So the distance of r, which is the distance of r? This is the distance, position vector. Yeah, that is a position vector. So what is r? Now this is y-axis, this is x-axis. So r can be written as Pythagoras theorem apply pannunga. So under root of x square plus y square, that is your vector r. So I am substituting that also. Okay, when you go to express your vector r. So now move on. So you can substitute lambda. So what can you substitute lambda as? Lambda into dl upon r square. So r square value I am substituting. So r square will be root of x square plus y square. The r, and r square, so whole square. Okay, into, now in the place of dl, na dx potukrayana. I have taken a small element in the x direction. It is linear distribution, so x direction at the cross, so into dx. Okay, so I am substituting. Simple. So and then what we do? Now we look at here. Electric field component along y-axis is upwards. But don't you think x component will have two electric field components? Isn't it? One on the left, one on the right. In the side na or chinna dx element eduthukite appadina, that will also experience one more electric field due to x direction on the right side. Equal and opposite electric fields can be cancelled out. So only the y electric field will be present. Okay, so electric field component due to y axis only will be there. So other one you go and substitute. On the mari you will get the relationship. So you move on and substitute the electric field components, the dE components due to x-axis, okay, due to dx axis cancel out each other. So rendume cancel aayaro. This dE and this also dE would get cancelled out. That is, which component is that? dE sin theta components would cancel out. Both are equal and opposite, they will cancel. Mele mattum ungalku rendu dE cos theta component irukku. So what is the total electric field on the y-axis? So electric field components on the y-axis is nothing but 2 times dE cos theta. Yeah, we are adding them. Both are on the same axis, so you can add them. Okay, vector addition. So you will get 2 dE cos theta. So I go and substitute that. Okay, so we can represent that as 2 dE cos theta. So koi substitute pannunga. So the total electric field can be written as E is equal to, it is integration of dE component along which axis? Along y-axis. So along y-axis how many components were there? There were 2 components. So it is nothing but cos theta. Okay, it was only the cos theta component. So let me write it as dE into cos theta. Nama kandupidichu vechirkom that values. So dE times cos theta irukum. And from where it is varying. It is varying from minus infinity to plus infinity. Isn't it? We took an infinitely long charge wire. So the limits were the minus infinity to plus infinity potukunu. 2 components are there. Add both the components. So 2 times integral. So you can let it as 0 to infinity. And now you consider both. Minus infinity to plus infinity. So can we write it as 2 times? Yes, we can write it as 2 times from the limits as 0 to infinity. Cos theta. Adukapra dE value substitute pannunga. What is the value of dE? We have already found out. Okay. It is lambda into dx upon x square plus y square. Okay, we are substituting this value. So like this, you will have to go for a simplification. Now you apply, you go by the method of substitution. In integration, so we go by the method of substitution. The triangle, here we got a triangle. So in the triangle, x y theta relate pandrom. So which is the trigonometric ratio that relates x, y and theta? Triangle x and y are opposite and adjacent sides, and you have theta. The trigonometric ratio that relates opposite and adjacent side is
tan theta.
Yeah, tan theta. So x is equal to y tan theta, because tan theta is x upon y. isn't it? So we will use x is equal to y tan theta. Okay, so here again maths we apply, we put x is equal to y tan theta. So நமக்கு dx வேணும் இல்லையா, so dx வேணும் அப்படிங்கிறதுக்காக நம்ம இந்த ரிலேஷன் கொண்டு வரோம். So differentiate, when you differentiate you will get dx is equal to, so y, differentiation of tan theta, differentiation of tan is secant square theta into d theta ன்னு வரும். இது வந்து differentiation concept. Differentiation of tan is secant square theta into d theta. சரிங்களா? So we will get like this. So இதை கொண்டு போய் நம்ம வந்து dx இடத்துல substitute பண்றோம். So அப்ப நமக்கு என்ன கிடைக்கும்? You will get 2. So constants எல்லாம் வெளியே எடுத்துருங்க first. So constants is lambda. You can take it out. Okay. அதுக்கப்புறம் you can also take out lambda you can take, I think k we represented, we didn't represent the k, right? Yeah, k is also there. Okay, so you can take 2 outside, k can be taken outside, lambda can be taken out. So integral, so the range is from theta. Ipo theta nama eludhumbodhu, so the theta is nothing but angle. So from 0 to 90 தான் நம்ம pi by 2 ன்னு எழுதுவோம். Why am I taking 0 to 90? Because in the theta வந்து is an acute angle, but when the wire is infinitely going, extending on both the sides, the theta will become 90 at some point of time. Okay, so that is why it is 90. So 0 to 90. Okay, so we take it as 0 to 90 cos theta into substituting in the place of dx. Dx வந்து y into secant square theta into d theta. Okay, divided by, and the x square plus y square இருக்கு இல்லையா, நம்ம அதை substitute பண்றோம். x square வந்து என்னன்னு எழுதிக்கலாம், x வந்து y tan theta னா what is x square? y square tan square theta ன்னு எழுதிக்கலாம் இல்லையா. So I am substituting that and take common out எடுத்துருங்க. So you will get it as x square. In the place of x square I am substituting y square tan square theta. So let me substitute that. So y square tan square theta plus y square. Enna common out inga, y square வந்து common out. So இத வந்து நம்ம எப்படி எழுதிக்கலாம், y square, open the brackets, 1 plus tan square theta. What is 1 plus tan square theta? Trigonometric identities. Secant square theta minus tan square theta is 1.
Secant square theta, sir.
So what is 1 plus tan? Secant square. Very good. So you can simply say this as y square secant square theta. Adha kondu poi nama substitute pandrom. Seriya? So you will get the answer as 2k into lambda integration 0 to pi by 2. Mela vandu you had cos theta into y into secant square theta into d theta. கீழ வந்து நம்ம எல்லாம் substitute simplify பண்ணிட்டோம். So y square secant square theta. What is getting cancelled? Both secant square gets cancelled off. One y also you can cancel. So what is left? Just the y is left, isn't it? So y is left. Yes, y you can take it out. So 2k lambda by y integration 0 to 90 cos theta into d theta. So what is integration of cos? Integration of cos one is
minus sin theta, sir.
Yes, minus sin theta. கொண்டு போய் substitute பண்ணுங்க. So 2k lambda by y integration of cos வந்து minus sin, limits from 0 to 90 degrees. Pi by 2 வந்து radiansல இருந்து நீங்க degrees convert பண்ணிக்கோங்க. So 90 degrees. Then simplify. So 2k lambda upon y, upper limit minus lower limit. Upper limit வந்து என்னது?
pi by 2.
Upper limit is 90. So minus sin 90. How much is sin 90? 0 இல்லையா?
1, sir.
0 or 1?
Sir, sin 90, 1, sir.
Sin 90 is 1. But integration of, just check it. Integration of cos, is it minus sin? I think it is sin, no? Minus varadu இல்லையா?
No, sir. Minus sin theta, sir.
Sure, bina differentiation வந்து differentiation of cos, I think it is minus sin. isn't it? So இங்கே வந்து integration of cos plus sign தான், it is opposite, just check. Okay, it has to be plus. So you will get this as sin 90 minus sin 0, upper limit minus lower limit. So sin 90 on the 1, sin 0 on the 0. So your answer is 2k lambda upon y. That's it. So what is k? K is 1 by 4 pi epsilon naught. So 2 into 1 divided by 4 pi epsilon naught. கீழே ஒரு y இருக்கு, மேலே வந்து you have 1 lambda. So what can be cancelled now? 2 and 4 can be cancelled. So answer is lambda divided by 2 pi epsilon naught y. This is the answer. This is the electric field due to an infinitely charged wire extending from minus infinity to plus infinity. சரிங்களா? ஸோ உங்களுக்கு 4 ஆப்ஷன்ஸ் கொடுத்து ஒரு ஆப்ஷனில் வந்து lambda by 2 pi epsilon naught y கொடுப்பாங்க, இன்னொரு ஆப்ஷன் they will give you something else, lambda by 4 pi epsilon naught y. ஸோ அந்த மாதிரி they will give you options. Okay, so this is the derivation that we have seen. So like this we have derivations for different figures. ஓகேங்களா?
Okay, sir.
Yeah. So I have taken some extra time, sorry about it, but I hope it was useful. So we have seen these concepts today in today's lecture. Okay.
Okay, sir.
Yeah, with this we will wind up and then we will continue in the next class. Okay. Yeah.
Yes, thank you, Manish.
Thank you, sir.
Yeah.
Thank you, sir.
Yes.
We have scheduled a class at 9:15.
Okay.
Okay, no problem.
Okay.
No problem.